I guess you could say that.
Yes, bonding. Actually, the bonding means attraction.
Also, sir, you did not put up the notes from the lecture.
Yes, after the completion, inshallah, tonight, inshallah, I will upload the full PDF of atomic structure, right?
Okay.
Last time we have discussed electronegativity, right? Electronegativity, Pauling scale. And then we move to ionic bonding, right? Today's
Yep.
lecture number 10, ionic bonding. Now, what is ionic bonding? In O level, you have studied ionic bonding, right? Can you tell me what is ionic bonding?
Ionic bonding refers to a metal and a non-metal. Sorry, when a metal donates an electron to a non-metal, and it builds a electrostatic force of attraction which holds the two elements together.
Exactly. So the bonding is due to the, as you know that bonding is the name of attraction. In the ionic bonding, metal gives its electron to non-metal and form electrostatic force of attraction. This electrostatic force of attraction is known as bonding. Okay.
Okay.
So let's start ionic bonding. So ionic bonding. After the class, I will upload PDF of atomic structure. So ionic bonding. So ionic bonding, the bonding which is formed due to complete transfer of electron. Bonding which is due to complete transfer of electron. Complete transfer of electron. Transfer of electron. Such type of bonding is called ionic bonding. Now look at the example. Here we have sodium. Sodium has 11 electron. So 1s2, 2s2, 2p6, 3s1. This is sodium. And here you have chlorine. Chlorine is 1s2, 2s2, 2p6, 3s2, 3p5. 3p5. So you can see that in the third shell you have 1 electron. In the third shell you have 7 electron. 7 electron. So octet is not completed. Octet is not completed. For chlorine, octet is not completed. Octet is not completed. Octet is not completed. Now to get the full octet, this electron move to 3p of chlorine. This is called ground state configuration. Ground state. This is called ground state. Now the new configuration is 1s2, 2s2, 2p6. And here 1s2, 2s2, 2p6, 3s2, 3p6. Now here 8 electrons in the valence shell. Here 8 electrons. Octet is now completed. Octet is completed. Octet is completed. Now sodium has one less electron. Chlorine has one more electron. Chlorine has one more electron. That's why negative. Now here sodium has 10 electron. Chlorine has 18 electrons. So sodium attain neon configuration. Neon configuration. Chlorine obtain argon configuration. So the driving force is octet and to attain noble gas configuration. Are you getting my point or not?
Yes, sir, getting.
Okay. So ionic bonding is due to the complete transfer of electron. Ionic bonding is due to the complete transfer of electron. Ionic bonding is due to the complete transfer of electron. Now look at sodium structure. This is first shell. This is second shell of sodium. And this is third shell of sodium. This is sodium. Now sodium has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Chlorine has 1, 2, 3, 1, 2, 8 electrons. So this is sodium. This is chlorine. Now this electron is given to this chlorine. This is sodium. Now, when you give this electron, shell is removed. So, positive charge is developed on sodium. Now, this is chlorine. This is chlorine. So, one electron is added here. One electron is added here. So, negative charge is developed. So, electrostatic force of attraction is developed between positive and negative. This attraction is called ionic bonding. This attraction is called ionic bonding. Now, can anyone explain how to form ionic bond? What is the procedure of formation of ionic bonding? Yes, anyone? How ions are formed?
By losing electrons or gaining electrons?
Yes, can you explain? Give the example of sodium chloride and repeat the whole procedure again.
Okay, so the configuration of sodium is 1s2, 2s2, 2p6, 3s1. That's the atom ground state, and then once it turns into an ion, it loses its 3s1 group to complete its outer shell, because it's easier to lose one electron. As a result, it forms Na plus, which gets the plus instead. And then and the configuration is equivalent to that of neons, right? As for
Yes.
chlorine, on the other, the ground state is the formula 1s2, 2s2, blah, blah, blah. And then once turns into an ion, it tends to gain an electron, and the formula turns into everything's exact same except it's 3p6 now. And the configuration is quite similar to that of argons. And then what simply happens in this case is that Na, which is sodium, tends to lend its electron to chlorine. Chlorine gains that electron, and both of them, complete their outer shell. This electrostatic force between these two particles, a positive and negative, results in ionic bonding being formed.
Exactly. Now, write few points for ionic bonding, right? First is, what is ionic bonding? Ionic bonding is due to complete transfer of electron. This is your first point. Complete transfer of electron. Point number 2, electron donor. Electron donor become positive, known as cation. Known as cation. For example, this is sodium. Sodium give electron. So this is cation. Point number 2. Point number 3, electron acceptor. Electron acceptor becomes negative, known as anion. For example, Cl get an electron and form Cl negative. This is anion. This is anion. So ionic bond is formed between the ionic bond is formed due to the attraction between the cation and anion. This attraction is known as electrostatic force of attraction. So point number 4 is ionic bonding is the attraction between sodium positive and Cl negative. Cl negative. Or you can say that cation and anion. Cation is sodium and anion is chlorine. This attraction is known as electrostatic force of attraction. This attraction is known as electrostatic force of attraction. Electrostatic force of attraction. Point number 5. Ionic bonding is the strongest bonding. Ionic bonding is the strongest bonding because of two reasons. Because of two reasons. Because of two reasons. Number 1, electron transferring is involved. Electron transferring is involved. Point number 2, attraction between oppositely charged ion. Charged ions. Now, Isa, can you tell me why ionic bonding is the strongest bonding?
Sir, because electron transferring and attraction between two oppositely charged ions.
Exactly, because of the two reasons. First is electron transferring is involved. Number 2, it is the attraction between oppositely charged ions. Now, next point. Point number 6. Electron donor. Electron donors are mostly metal. As Huzaifa said, electron donors are mostly metals. As Huzaifa said that the bonding, ionic bonding is between the metal and non-metal. So electron donors are mostly metals. Metals like group 1 and group 2. And group 2. Point number 7. Electron acceptor are non-metals. Non-metals like group 17. Group 17 halogen. Group 17 halogen. Fluorine, chlorine, bromine, iodine, astatine. These are non-metals. So it means metals and non-metals. Metals and non-metals form ionic bonding. Formed ionic bonding. Why? To get the electronic configuration of noble gases. Configuration of noble gases. For example, sodium. For example, sodium. For example, sodium. For example, sodium. Here we have 3s1. So in the third shell, you have only one electron, which is 3s1. Now chlorine. Now in the p orbital, we have 5 electrons. 1, 2, 3, 4, 5 electrons. So octet is not completed. Now 3s electron. Now 3s electron of sodium transfer to 3p of chlorine. Now this electron is transferred. So 3s electron now next point, 3s electron of sodium transfer to 3p of chlorine. 3p of chlorine. 3p of chlorine. 3p of chlorine. 3s electron sodium transfer to 3p of chlorine. Now new electronic configuration is this one. After point number next, point number 9, and then point number 10. Point number 10, sodium attain neon configuration. While chlorine attains argon configuration. Argon configuration. So the driving force is noble gas configuration. Noble gas configuration. As a result, ionic bond is formed. This is called electrostatic force of attraction. Electrostatic force of attraction. Electrostatic force of attraction is between oppositely charged ions. Oppositely charged ion. This diagram is called dot and cross diagram. This diagram is known as dot and cross diagram or Lewis structure. Now make the heading representation of ionic bonding. Representation of ionic bonding. Second subheading is dot and cross diagram. Dot and cross diagram. First point, another name is Lewis structure. Another name of dot and cross is Lewis structure. Another name of dot and cross diagram is Lewis structure. Point number 2. Only valence electron are used to display Lewis structure. Question: draw Lewis structure of the following. Draw Lewis structure of the following. NaCl. NaCl. So here we have sodium. Sodium is 11,281. Here we have chlorine 17,287. So this electron is transferred to this chlorine. Now the new configuration is 2,8. Here 2,88. So in the last shell we have 8 electron. We have 8 electron. So draw only valence shell. So how many valence electrons are in sodium? Yes. How many electrons? Yes. In sodium ion. In sodium ion. Yes.
Yeah, now after ion, it's going to be 8.
8 electrons. Very good. So here we have sodium. So 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. So here we have positive charge because it has one less electron. Now, can you tell me how many valence electron in chlorine? Minus? Yes. Can you tell me how many valence electrons? Yes. 8. 8. Correct answer, 8. Here we have dot. We need cross. We need cross. Cross, 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 cross. Now I have committed a mistake. Can you tell me the what mistakes I have done?
Sir, one cross should be a dot.
Yes, chlorine has 7 valence electron. So this electron is not belong to chlorine. It should be from sodium. Now, electrostatic force of attraction is developed. This electrostatic force of attraction this electrostatic force of attraction, this electrostatic force of attraction is called ionic bonding. This electrostatic force of attraction is called ionic bonding. This is electrostatic this attraction is called electrostatic or electrovalent attraction. This attraction is called electrostatic force of attraction. This is sodium. This one is chlorine. Sodium electron. This is chlorine electrons. Sodium electrons, chlorine electrons. Now question number 2, calcium oxide. Calcium oxide. This is calcium. This is oxygen. Calcium has 20 electron, oxygen has 8 electron. So calcium is 2, 8, 8, 2. Oxygen is 2, 6. Now this electron is moved. So new configuration would be 2, 8, 8, 2, 8. Now, can you tell me how many electrons are in calcium? After donating one electron, after donating 2 electrons. Yes. How many valence electron?
8.
8 electron. So now this time this is calcium, but the charge is +2. And oxygen is here. This is oxygen. So yes, now it has 2 electrons. And the charge would be -2. -2. Dot indicates calcium electron. Calcium electron. And this is chlorine electron. Chlorine electron. Yes, beta, any question?
No, sir.
No, sir.
Now question. Yes, do you have any question?
No. I understand.
Now, okay. Question number 3, calcium chloride. Question number 3 is calcium chloride. This time you have 1 calcium and two chlorine atoms. Electronic configuration of calcium is 2882 and chlorine is 287. 287. So calcium donate here 1 electron to this chlorine and 1 electron to this chlorine. So two atoms of chlorine needed. Why? Because calcium gives 2 electrons. So 2 atoms of chlorine are needed. Now 2 electrons are donated. Now here you have calcium. Here we have calcium. Calcium. 2 chlorines are required. This is 1 chlorine. Another chlorine is required. This is another chlorine. This is chlorine. Chlorine has 1 electron of calcium, each chlorine atom. So this is electrostatic force of attraction. This attraction is called ionic bonding. This attraction is called ionic bonding. Now, after giving or accepting 1 electron, it becomes 288. This becomes 288. 288. So all obtain argon configuration. calcium and chlorine both attain argon configuration. Configuration 288. Any question?
No, sir.
Not really,
Any
sir.
question? Okay. Alhamdulillah, Alhamdulillah, Alhamdulillah. Now next is energies involved. Energies involved in ionic bonding. Three energies. Three energies are involved. Number one, ionic bonding. Number two, covalent bonding. Are you listening my voice or not?
Yes, sir.
No, sir.
So ionic bonding is the energy. Covalent bonding is the energy.
No, sir.
So please be attentive. So first energy is ionization energy. First energy is ionization energy. Second is electron affinity. And third one is lattice energy. Lattice energy. So first is ionization energy. We have learned all about the ionization energy in the previous classes, right? We also ionization energy. Now Isa, define what is ionization energy.
So it is when an atom in a gaseous state loses an electron and becomes an ion.
This definition has 3 marks. Yes.
So how many marks did my definition get?
3 points, right? So first is, it is the amount of energy required it is the amount of energy required point number 2, to remove an electron point number 3, from gaseous atom to form gaseous plus 1 ion. Example, sodium gas. Now electron is removed, cation is formed. This is ionization energy. Delta H is positive. Second is calcium. Calcium gaseous. Remove an electron. Calcium plus gaseous. Then remove another electron. It becomes calcium plus 2 plus E. All should be in gaseous state. This is called first ionization energy. This is endothermic. This is second ionization energy for second electron. Delta H is positive. So this energy, required energy, this required energy is called ionization energy. Now cation is formed. Cation is formed and ready to make ionic bonding. Now second is electron affinity. Second is electron affinity. It is the amount of energy released. It is the amount of energy released. Now to gain electron, from gaseous atom to form gaseous minus 1 ion. This is electron affinity. Now equation is chlorine gaseous atom, chlorine minus ion is formed. This is not a cation, this is anion. This is called anion. Delta H is negative. Similarly, oxygen. Oxygen gas need 1 electron. So it becomes O minus gaseous anion. When second electron is added, so they repel. No bonding, no anion, no bonding, no cation, no anion. Are you getting my point or not?
Yes, sir.
Because negative repel. If you provide energy, O minus 2 is formed, but this delta H is positive. Because energy is given. So second electron affinity is negative, positive. Because why second electron affinity is negative, positive? Because electron and anion repel each other. They repel each other. To overcome this repulsion, to gain an electron, energy is required. That's why second electron affinity is endothermic. Now question is, why is first electron affinity is exothermic and remaining as second electron affinity? First electron affinity is exo and remaining second electron affinity endothermic. Answer: because first electron affinity is exothermic because of the attraction between positive nucleus and upcoming electron. That's why first electron affinity is exothermic. While second electron affinity is endothermic. Endothermic because there is repulsion between anion and upcoming electron. Are you getting my point or not? Both are
Yes, sir.
negative. To overcome their repulsion, to give an electron or to accept an electron, so there is repulsion between O minus and negative. So to overcome this attraction, delta H is positive. So there is a repulsion between anion and upcoming electron. To overcome their repulsion, to get an electron.
Sir, so whenever there is attraction, it is exothermic, and when there's repulsion,
Whenever
it's
you have attraction, it is exothermic. Whenever you have repulsion, it is endothermic. Beta, any question?
No, sir.
Now you have cation and anion. Last is lattice energy. Lattice energy.
Sir, could you scroll up for a minute?
Yes.
Okay. You can keep writing.
Okay. Next is lattice energy. So It is the amount of energy released. It is the amount of energy released when gaseous ions, cation and anion, combine to form solid ionic compound. For example, sodium plus gaseous, Cl negative gaseous. So whenever gaseous ions combine, NaCl solid is formed. This delta H is negative, known as lattice energy. Yes, Peter. Any question?
No, sir.
Now, Isha, can you repeat lattice energy, ionization energy, and electron affinity? Can you repeat?
Sure. So, sir, in ionization energy, the definition is it is the amount of energy required to remove an electron from gas and to form from gas atom to form gaseous plus one ion. Now, for example, sodium gas will give you sodium plus one ion gas plus one electron, and the delta H will be positive over here. So that's endothermic.
Exactly.
And electron affinity, it is the amount of energy released to gain an electron from gas atom to form gases minus one ion.
Very good.
For example, electron plus chlorine gas will give you chlorine minus one gas. So here there is a negative and positive charge, so it will be
It's
exothermic.
better to use gaseous, not gas.
Okay,
Because
gaseous.
O minus 2 is not gas. It's gaseous, right?
Yeah.
Yes. Isa, carry on.
Okay, so O gaseous plus one electron will give you O minus gaseous. And then after that, we can't do the second ionization because they both will repel, so there will be no bonding.
But if you want to give electron to oxygen, you know that oxygen has negative 2 charge, so you must give it one electron. Now you have repulsion because O minus 1 is negative, electron is negative, they repel each other. Now energy is required to overcome this repulsion to give one electron to the oxygen minus 1.
Yes. So when we'll supply the energy, so it will become endothermic.
Very good. Now DI. DI is shortcut or very important points, doctor instruction. DI is doctor instruction, right? Now look at the formation of ionic bonding. You have sodium gaseous ion, gaseous atom. You have chlorine gaseous atom. Now remove one electron from sodium. Sodium becomes sodium plus gaseous. Now give this electron, remove electron to chlorine. It becomes chlorine minus gaseous. So this is the electron transfer. Now, can you tell me when electron is removed from gaseous to form gaseous plus one, name of the energy would be? Yes, can you tell me the energy involved in this reaction?
So ionization energy.
Ionization energy. So this is very good. This is ionization energy. Okay. When chlorine gets electron, anion is formed. This energy is called Just beta, when chlorine accepts one electron from sodium, energy is released. Can you tell me the name of the energy when electron is gained by any element?
Sir, will it be lattice energy when two combine?
No, when chlorine gets an electron. I am talking about this.
Electron affinity.
Electron affinity, very good. So electron affinity. Electron affinity. When these two combine, NaCl solid is formed. Can you tell me this the name of this energy? When gaseous ion combines, lattice energy.
Lattice.
So this is how ionic bond is formed. This is the correct picture, right? In O level, you studied incomplete picture, right? This is the complete picture of ionic bonding. Can I move forward?
Yes, sir.
Okay. Isa,
Yes, sir.
can I start tomorrow class at 3?
3 Pakistani time.
Yes, 3 Pakistani time. Is it fine for you?
Yeah. Can you make it 3:15? Then I guess I can join at
3:15. 3:15.
Yeah. Yes.
Okay, 3:15. Mohammed, Huzaifa, Mohammed, is it fine? 3:15.
That'd be around 1:15 here, right? So
Yes.
I guess I could do it. Yeah, sure. I don't really mind.
Okay. Okay. Now the new timing is Pakistani 3:15, right?
Yes, sir. This is
Tomorrow
only for
you have.
Sunday.
Yes, it is only for Sunday.
Yeah. Okay. It's fine.
Saturday 12:45, and on Sunday it would be from 3:15. Okay, next is lattice. After lattice energy, new topic is crystal lattice. Crystal lattice. Crystal lattice. Now, you know that when gaseous ion, cation and anion combine, they arrange themselves in a proper pattern. Whenever gaseous ion, positive and negative, combine, they arrange themselves in a particular manner. This arrangement is called crystal lattice. When gaseous, cation, and anion combine, they arrange themselves in a particular manner. This arrangement is called crystal lattice. crystal lattice. This arrangement is called crystal lattice. Now question, draw crystal lattice of NaCl. Draw crystal lattice of NaCl. Now look at this picture, right? So we have another type. This is crystal lattice. This is no need to learn the lattice, but you have to memorize the pattern. How to place ions. All now place sodium and chlorine. Let's suppose this is sodium. This is sodium positive. Let's suppose this is sodium positive. Now place this sodium. Place sodium here. Place sodium here. Place sodium here. No, here. Place sodium 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 here. Now you need chlorine atom, right? This is Cl minus. So place chlorine here. 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 This is electrostatic bonding. Place chlorine here. Place chlorine here. Very, very complicated picture. Chlorine here. Chlorine here. Chlorine here. Chlorine is here. This is lattice. Here we have chlorine. Here we need sodium. So this is lattice structure of sodium chloride. Now you can look it again. Again you have lattice. Remove these signs. Now look at this ionic lattice again. Join this. Now consider this blue spot, right? This is sodium. So one sodium is surrounded by one chlorine. This is chlorine, this is chlorine, this is chlorine. And chlorine is surrounded by sodium. Here we have sodium, here we have sodium, here we have sodium, here we have sodium. Sodium is surrounded by chlorine. Here we have chlorine, here we have chlorine. Here we have chlorine, here we have chlorine, here we have chlorine, here we have chlorine. Here chlorine, here chlorine, here chlorine. Now each chlorine is surrounded by sodium. Here we have sodium, here we have sodium, here we have sodium, 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 sodium. Again chlorine. So sodium is this one, and chlorine is this one. So this particular arrangement is called lattice, crystal lattice. Beta, any confusion, any question? Any question?
So we need to learn how to draw this.
No need to draw, no need to learn, right?
Okay.
Now look at the question. Examiner asked 9701 paper 2, October, November 2003. October, November, paper 2. This one for 3 marks. Question number 1. Oh. This is the question. Now, look at the question. Draw sodium chloride lattice, right? Sketch part of crystal lattice. Part of crystal lattice. Now, you can easily draw crystal lattice. Part of crystal lattice. Draw a square. Now, draw another square. Now, join these lines. This is single unit. This is single unit. Part of the crystal it is, right? Now, write here sodium positive. Here you have sodium positive. Here you have sodium positive. Here you have sodium positive. Sodium positive. Each sodium is attracted by negative chlorine. Negative chlorine. Negative chlorine. Negative chlorine. Here you have sodium. This is a part of crystal lattice. You can see that one sodium positive is surrounded by 7 chlorine ion. 6 chlorine ion, sorry, 6 chlorine ion. Six chlorine ion. Four. This is fourth one. This is fifth one. This is sixth one. So one sodium is attracted by six chlorine ions. 6 chlorine ion. Similarly, if you have one chlorine, if you have 1 chlorine, so it is attracted by 7 sodium, 6 sodium. 6 sodium. So this is so blue one is sodium positive, and the red one is chlorine minus, chlorine minus, chlorine minus, chlorine minus, chlorine minus, chlorine minus. So this is crystal lattice, right? Single unit. 1 sodium is surrounded by 6 chlorine. This is called coordination number. So inshallah,
Sir?
tomorrow, yes,
Sir, how did you know that there's 6 chlorine around 1 sodium?
because I know, right? It's a fact.
Oh, okay.
It's a fact. Each one has different coordination number, right? As you know that coordination number of male in Islam is 4. You can form 4 bonds, right? Similarly, sodium can make 6 bonds. This bonding is called coordination number, right? This would be our lecture number 11. Any question?
No, sir.
Okay. Tomorrow, inshallah, 3:15. Allah Hafiz.
Allah Hafiz, sir.